There's one more issue to do with these double bonds, and it has to do with the sp2 hybridization associated with carbon forming a double bond. So let's imagine the simplest molecule that we can look at this with. This is going to be 2-butene. Because this is an sp2 hybridization, it's actually a trigonal planar shape of molecule. That means that this isn't an equal tetrahedron where all of these directions are free to rotate or do whatever they want, but it means that this is all in a plane and there's actually a pi orbital that exists above and below the molecule, fixing it in space so it's unable to rotate. What that means is the carbon that's up versus the carbon that's down is actually a slightly different molecule. These two carbons cannot rotate relative to each other, so since they both go up, or as opposed to if one of them went up and the other went down, well, these changes may seem sort of silly, they are actually meaningful, and these two molecules will actually have different properties. As a result, in their naming system, we need to find a way to represent the difference between when the two things that are the same are on the same side of the sp2 or the same side of the triangle, or whether they're on opposite sides of the triangle. That's where we use the words cis and trans. Cis is a fancy way of saying same, and trans is a fancy way of saying different. So here, this would be cis 2-butene, and this would be trans 2-butene. And because of the shape of this molecule, if we imagine this thing packing, we would actually see a slightly different boiling point for these two molecules based on the fact that the overall shape of the molecule in one would be more able to form an induced dipole than it would in the other. So